Hello to everyone. So, still we are in fuels and combustion, and our topic for this lecture video is about combustion of solid fuel. But before we go on to our discussion proper, I want to discuss first and review the methods on calculating heating values of fuels by formulas. This is for fuel oils. Meron kasing student sa akin na nagtanong about this one kasi yung isang presentation ko ay we only tackle ASME formula for petroleum products, which is higher heating value is equal to 41,130 plus 139.6 degrees API in kilojoules per kilogram, where degrees API is defined by this equation. And the other method is by Bureau of Standards with a higher heating value equal to this term. So the other one which is requested by someone is the Baum scale. So I have not included this one in our previous discussion on heating values of fuels, especially for fuel oils. So in Baum scale, higher heating value is equal to 18,250 plus 40 times the quantity degree Baum minus 10. This is in BTU per pound. And the degree Baum is equal to 140 divided by the specific gravity of the fuel at 15.6 degrees Celsius or at 60 degrees Fahrenheit minus 130. So meron siyang pagkakaiba ng konti dito sa degrees API kasi dito ay 141.5 and 131.5 samantalang dito ay 140 minus 130. So in our previous example, I showed to you an example of how to use these formulas as ASME formula in Bureau of Standards. For this example, which we calculate the higher heating value of diesel fuel oil with density of 0.846 kg per liter. So we compute for the specific gravity by this formula and we find 0.846 and we compute for the degrees API because it is needed here in ASME formula. So we got 35.6 degrees API using this formula. And we have found out that the higher heating value using the ASME formula is 46,122 kilojoules per kilogram. And for Bureau of Standards, that is 45,422 kilojoules per kilogram. So now here, using the Baum scale, we have this formula. We have to check out if the higher heating value that we will get is equal to the two previous formulas. So HSB is equal to 18,250 plus 40 times degree Baum minus 10. So we compute the degree Baum with this formula. So given the specific gravity equal to 0.846, then we have degree Baum is equal to 32.79 by substitution of the specific gravity. So using this formula for higher heating value, we arrive at this result 19,161.6 BTU per pound. And converting that to kilojoules per kilogram, we got 44,573.8 kilojoules per kilogram. If we compare that to the previous example, we have 46,122, 45,422, and now we get 44,573.8. So there are discrepancies, and according to the higher heating value given in this table, that is 45,600 kilojoules per kilogram. So that's the method how we compute HSB using Baum scale. So tatandaan nyo itong tatlong ito, the ASME formula, the Bureau of Standards, and the Baum scale. So these are formulas used for calculating heating values for fuel oils. You cannot use that for solid fuels. So let us go to our lecture proper. The calculation of air quantity for burning coal. This is what we call stoichiometry. Coal is the most widely used fuel source used to produce electricity. Air is necessary to provide oxygen for burning coal. It is the chemical reaction between carbon in coal and the oxygen in the air that produces much heat energy. So, paano natin susunugin yung coal? So, we will use, siyempre, yung what is abundant sa atin, yung air. Dito sa air, ang napapakinabangan lang naman dito, siyempre, yung oxygen niya. So, para masunog mo yung coal, the coal requires oxygen. There are three elements in coal that combine with oxygen in the air during the combustion process. The most important element is carbon. This makes up about 30% to 60% of the substance. Hydrogen makes up about 1% to 3%, and sulfur 0.3% to 3%. The other elements found in coal are nitrogen, which can make up about 1 to 2% of the substance, and oxygen 5% to 12%. Oxygen is also used up in the combustion process. So yung oxygen na nandun sa coal ay nagagamit din yun during the combustion process. The exact amounts of its elements depends on the type of rank of coal, how the coal was formed million years ago, and the location of mines from which the coal is sourced. So, sabi ko nga doon sa isang video, we have studied this one. Ang element sa coal ay depende kung saan siya nakuha at kung kailan siya na-form. Now we go to combustion. By definition, combustion is the combination of combustible elements of fuel. So, tatandaan nyo, combustible elements of fuel, these are carbon, hydrogen, and sulfur. So, it is combined with oxygen to release the energy. So, for hydrogen, it combines with oxygen to form water and heat. So, ito yung hydrogen natin, H2. Ang H2, ang hydrogen ay diatomic element po yan. Lagi siyang may subscript na 2. Ano po? So, hydrogen plus oxygen, which is also diatomic element, it becomes water. So, H2 plus O2 is equal to H2O. So, ano tong nanditong 2? Right? So, yan kasi binalanse yan. So, balancing of the equation. Kasi, H2 plus O2, meron tayong water, H2O. Pero dito sa reactants natin, meron tayong O2. So, may dalawang oxygen. Right? So, dito, isa lang ang oxygen kasi walang subscript. So, babalansin mo siya, lalagyan mo siya dito ng 2. So, 2 times H2. O yan. So, may dalawa ka na ditong oxygen. Yan. So, balansin ang oxygen mo. Then, dito naman, kung titingnan nyo, meron tayong dalawang hydrogen times 2 pa. Diba? H2 times 2. So, may 4 ka dito. So, you have 4 here. So, dapat dito sa reactants, meron ding 4. So, kaya nilagyan dito ng 2. So, originally, H2 plus O2 lang yan is equal to H2O. Then, by balancing, naging siyang 2H2 plus O2 is equal to 2H2O. Balance siya. Dalawang oxygen, 4 ang hydrogen. So, pag binasa mo ito, this means that 4 kg of hydrogen sa mass, di ba? Kasi ang hydrogen, ang molecular mass niya is 1. So, 1 times 2 is equal to 4. So, sa oxygen naman, 32 kg siya kasi O2 siya, di ba? So, ang oxygen ay 16 ang molecular mass or molecular weight. So, 2 times 16 is 32. Then, we have here, pag sinum up mo siya, simple ito, 36 ito. Kasi meron ka ditong 16 times 2, 32, plus ito 4. So, 32 plus 4 is 36 kg. So, makikita nyo naman yan dito, 4 plus 32 is equal to 36. So, yan ang ibig sabihin nito. So, therefore, kung i-reduce mo yan sa lowest term, i-divide mo siya sa 4 lahat. So, 4 divided by 4, 1. 32 divided by 4, that is 8. 36 divided by 4 is 9. Or, 32 kilogram of oxygen is required to burn 4 kilograms of hydrogen. So, ito ang reactants natin. 32 kilograms oxygen and 4 kilograms of hydrogen. And 32 divided by 4 is 8. So ang ibig sabihin nito, you need 8 kilograms of oxygen to burn 1 kilogram hydrogen. Kaya 8 kilogram of oxygen per kilogram of hydrogen. So this is the oxygen and the fuel ratio. Ito yan. So same thing will happen when we burn sulfur with oxygen. It forms sulfur dioxide. So sulfur plus oxygen, O2, is equal to sulfur dioxide. Ngayon kung makikita nyo to, balanse na siya agad. Kasi isang S, dalawang oxygen. So hindi mo nalalagyan dyan ng mga numerical coefficient. Kasi balanse na siya. Then you get the molecular weight of sulfur, that is 32 kilogram. Kasi ang sulfur is 32. Ang oxygen ay 16. So 16 times 2, 32. So this one becomes 64 kilogram of sulfur dioxide. So ibig sabihin yan, pag dinivide mo siya ng 32 all the way, so that is 1 kilogram of sulfur plus 1 kilogram of oxygen is equal to 2 kilogram of sulfur dioxide. So ang reactants natin ay ito. So 1:1 siya. So therefore, 1 kilogram of oxygen is needed to burn 1 kilogram of sulfur. Now for carbon, it combines with oxygen to form carbon dioxide in heat. So carbon plus oxygen is equal to carbon dioxide, CO2. So makikita nyo, wala naman uli siyang coefficient kasi balanse na siya. 1 carbon dito, dito 1 din. May O2 dyan, may O2 ka rin dito. So, balanse na siya. Then you write the molecular weight of carbon, that is 12, carbon 12. And oxygen again, 2 times 16, 32. So, this produces 44 kilograms of carbon dioxide. Ito, 44 yan. Kasi 12 plus 16 din yan. So therefore, if you divide this by 12 throughout, this becomes 1 kilogram divided by 12, 2.67, 44 divided by 12 equal to 3.67. Or in short, there are 32 kilograms needed for oxygen to burn 12 kilograms of carbon. So if you divide this, 2.67 kilogram of oxygen per kilogram of carbon is needed. Therefore, the minimum amount of oxygen required for complete combustion of coal, so yung mga combustible sa coal natin, sinabi doon, carbon, hydrogen, and sulfur. Yung kasing nitrogen ay hindi naman yung combustible. Yung nitrogen, hindi yan nasusunog. Pag pumasok yan sa furnace, lalabas din siya na nitrogen pa rin. Wala siyang reaksyon sa oxygen. So the only combustible component of coal are these three: carbon, hydrogen, and sulfur. So the mass of oxygen per mass of the fuel, this is coal, is now 2.67 C. Where do we get that? Ito yan, 2.67 kilogram of oxygen plus 8, okay, 8. Ito yan, 8 kilogram of oxygen per kilogram of hydrogen. 1S sulfur. Ito yan, 1 kilogram of oxygen per kilogram of sulfur. So, sinum up lang yan dito. Okay? 2.67 C plus 8H plus 1S minus oxygen. So, bakit sinubtract yung oxygen? Kasi yung oxygen na ito na nandun sa fuel, gagamitin yun sa combustion ng fuel mismo. So yung kailangan mong oxygen, mababawasan na. Okay? Kasi mayroon ka ng initial oxygen content dun sa fuel. So ima-minus mo yan sa kailangan na oxygen requirements. Kasi kung wala itong oxygen dito, ibig sabihin kung walang oxygen yung fuel, hanggang dito ka lang, wala ng negative O. Since merong oxygen dun sa fuel, nagagamitin dun sa combustion, so isusubtract mo siya sa requirements na oxygen. So this one, C, H, S, and O, these are taken from ultimate analysis in decimal. MO is the mass of oxygen, and MF is mass of fuel. Important to note, there are 0.231 kilogram of oxygen per kilogram of air. So the theoretical air, which is weight of theoretical air required to complete combustion of a fuel containing oxygen, carbon, and hydrogen and sulfur. So pag itong term na ito, dinivide mo siya sa 0.231, ang kalalabasan niya ay ito. Ito yung standard equation ng wata. So 2.67 divided by 2.31 is approximately equal to 11.53. 1 divided by 0.231 is approximately equal to 4.32. 8 for hydrogen divided by 0.231 is equal to 34.36. So since this one, kinumbine lang yung H and O, so minus O siya dyan. So pag kinumbine mo dito, i-divide mo siya ng 8 kasi 8H minus O, oxygen. So ibig sabihin niyan, kung ilalabas mo tong 8 sa algebra, 8 times H minus O over 8. Pag kinumbine mo tong dalawa, 8H minus O is equal to 8 times the quantity H minus O over 8. So, ito yun. H minus O over 8. So, kaya nagkaroon dito ng H minus O over 8. So, algebra lang yan. I-simplify nyo ito. Nilagyan lang yan dito ng H2. So, this is H2. Hindi siya H squared. Sorry. So, this is H2. Hindi siya squared. So let us take an example. So for this example, we are considering coal having ultimate analysis as follows. So kukuha tayo doon sa table 5-1 ng book na Power Plant Theory and Design by Potter. So let us choose one here. So let us choose this coal from the state of Alaska, county, Matanuska field. The rank is bituminous. So yan, yung may pula. Okay, so carbon is 71.2. Hydrogen is 5.92. Sulfur is 0.54. Oxygen is 13.76. So for this example, we will use the equation, this one. Let's start with this equation. Okay. Check na lang natin ito mamaya doon sa isa pang equation. So, using this equation, the theoretical oxygen required to burn this coal is then, so substitute mo lang yung carbon dito, hydrogen, sulfur, and oxygen. So, 2.67. So, ito yung carbon, hydrogen, in decimal, kasi 71.2, that is 0.712. 5.92, that is 0.0592. 0.54%, that is 0.0054, and 13.76%, that is 0.1376. Then we have 2.242 kg of oxygen for 1 kg of coal. So this is our computed mass of oxygen per mass of fuel. So let us compute for the weight of theoretical air required. So yung air kasi meron siyang oxygen and nitrogen. Ito pure oxygen ito. Pure oxygen. So paano kung gagamit tayo ng air? for combustion. Therefore, for atmospheric air, alam natin na by weight, that is 76.9 nitrogen and 23.1% oxygen. So, ibig sabihin, kada kilogram ng air, meron lang siyang 0.231 kg of oxygen. Kasi ito yung percentage, 23.1%. So, therefore, we have 0.231 kg of oxygen per kilogram of air. So, since this is in kilogram of oxygen per kilogram of coal, so, ang weight of theoretical air niya is 2.242 kilogram of oxygen per kilogram of coal divided by this one, 0.231 kilogram of oxygen per kilogram of air. So makikita niya, makancel ito, kilogram of oxygen, kilogram of oxygen. So tataas yan, bababa ito. We have 9.7 kilogram of air per kilogram of coal. So using the formula for wata, yung pinaka-formula talaga niya, so we just substitute again the values of C, H, hindi yan square, that is hydrogen, H2. And oxygen and sulfur, we have 9.676 kg of air per kilogram of coal. So malapit, di ba? 9.7, 9.676. So if the ultimate analysis is not given, but the heating value is known, so kung hindi given yung carbon, hindi given yung hydrogen, yung sulfur, yung oxygen, we cannot use this one, this equation, right? So this one is H sub 2, hydrogen, hindi po yan H squared. So nagkaroon lang ng typographical error po dyan. So paki-correct nyo lang po. That is H sub 2. So you cannot use this equation if hydrogen, oxygen, sulfur, and carbon are not given. But you can still compute for the weight of theoretical air using this formula. This is an estimation. Heating value in BTU per pound divided by 1340. So for the given coal, we got HSB is equal to 12,892 BTU per pound. So saan natin nakuha yan? So babalik tayo dito. Makikita nyo dito. So makikita nyo yan, 12,892 ito. So yan ang heating value. Okay? So we use that in this formula. 12,892 divided by 1340, we got 9.62 kg of air per kilogram of coal. So medyo malapit pa rin siya dun sa 9.676. Right, this one. 9.62 siya dito. Pero malapit. So that is another secret. So you just always take note of the conversion. Halimbawa, kung ang given sa higher heating value ay kilojoules per kilogram, you should convert that to BTU per pound. How? Ito yung conversion niya. 1 BTU is 1.055 kilojoules. 1 kilogram is 2.205 pounds. So malapit sa dyan. So yan ang gagamitin mong conversion of units. Now let's go to the weight of actual air. So ang kinompute natin ay theoretical air. Yun yung exact. Pag sinabi natin theoretical, yan yung exact na air requirements para magkaroon ng complete combustion. So we have calculated the minimum quantity of air required for complete combustion of 1 kg of fuel. But in actual practice, we supply air more than the theoretical minimum amount in order to ensure the complete combustion of the fuel because, this is the reason, all of the air supplied does not come into intimate contact with the particles of the fuel. So tama naman yun. Halimbawa, nagbo-burn ka ng coal, so susuplayan mo siya ng air. Through, halimbawa, meron kang fan, forced drop fan, yung dumadaan dun sa coal, sa combustion chamber niya, hindi naman yan lahat tatama dun sa fuel. Hindi lahat magkakaroon ng intimate contact. So you need to apply excess air. So that's why we have here WA, weight of actual air. This is equal to WATA times 1 plus E. Ang WATA is weight of theoretical air. So E is excess air in decimal. For example, Compute the air requirement for the previous example if the excess air is 50%. So if you want to have 50% excess air, para magkaroon siya ng complete combustion, masiguro mo na magkakaroon ng complete combustion, then we use this equation, Wa is equal to Wata times 1 plus E. So our computed air, 9.676. This one, using this formula. So multiplied by 1 plus the excess air, 50%, so 0.5. Then we have 14.51 per kilogram of air per kilogram of coal. So that's how we compute for the air requirements in the combustion of solid fuel, particularly coal. So ano ang importance nito sa engineering? Kasi ganito yan. So halimbawa, nagsusunog ka ng coal, yung power plant mo ay required niyang sunugin na coal. Requirement niyang fuel na dapat masunog per hour is 1,000 kilogram. So ito na ang basyan mo. So you need 1,000 kilogram of coal per hour. So ilang air ang kailangan? So ito yung multiply mo sa kanya. Kasi kailangan mo ng 14.5 kilogram of air per kilogram of coal. So if you are supplying 1,000 kilogram of coal per hour, so just multiply 14.514 times 1,000, that will become 14,514 kilogram of air per hour ka na. So multiply this by 1,000 kilogram of coal per hour. So makukuha mo yung kilogram of air per unit time per hour. So makancel yung kilogram per coal, makancel siya. Then you can compute for the air requirements per unit time. So ganun po yan. So diyan ka na mag-umpisa ng competition mo. So kung 14,514 kilogram yan per hour, so ano ang volume? So makompute ka na uli. Kasi alam mo naman ang density ng air, di ba? So magdidire-diretso ng computation mo. Pag na-compute mo na yung volume requirements, so makukuha mo na kung ano ang capacity ng fan, ng force drop fan na kailangan mo sa pag-supply ng air dun sa combustion chamber ng coal. So ganun po ang importance ng knowing the weight of theoretical air and weight of actual air in combustion of fuel. So hanggang dito muna. Next video we will tackle combustion of fuel oil. Yun namang mga gaseous and liquid fuel. Yun naman ang alamin natin kung paano ang combustion naman nun. Yan muna, salamat.